Okay, so we're going to go deeper into the two variable equations unit, which just involves a lot of graphing and whatnot. So first we'll be looking at rates and proportional relationships. When the falcon is in a dive, it can reach speeds at 242 miles per hour, making it the fastest member of the animal kingdom. The graph below shows a proportional relationship between distance and time. So this is the proportional relationship. Every hour, it's 242. So you can see every hour is 242. 242 miles. It's kind of graphed weird. Okay, so how does the speed of miles per hour represented by this relationship compare to that of the falcon? Wait, so the graph below shows a proportional relationship between distance and time. Yeah, the speed here is less. You can see it's at 200 for an hour. That's less than the speed they represented there. So the graph is different. So you should be able to know how to read the graph. So you can see here left and right is hours. So this is 1 hour, 2 hours, 3 hours, etc. And then these are the miles per hour. So that's 200 miles per hour and so on. The speed of a space shuttle orbiting the Earth is 17,600 miles per hour. The graph below shows the distance in thousands of miles traveled in T hours by a weather satellite orbiting the Earth, which orbits at a greater speed. Probably the space shuttle. That sounds a bit faster. Let's see. This is 1 hour is, yeah, that's going to be slower. But this is in the thousands of miles. So maybe it might be about the same. It's hard to say where that's at. I want to say it might have the same speed. Or it's going to be more for the space shuttle than, let's see. It's a little harder to read the graph, but if that's at 234, then let's split the 34 in half. 34 divided by 2 is 17. So it's going to be slightly slower actually for the satellite. This one's 17,600. It's kind of hard to read sometimes where the numbers are with the graph. And so pretty much these are all doing the same thing. You're seeing which is faster by looking at the graph or looking at the chart. Charlie can type faster than any of his classmates. He took a test and he showed he could type 700 words in 5 minutes. Fast recording typing speed is shown below. So that means, okay, so you want to find the rate. To find the rate, you're going to divide the total by the number of minutes. That will get you the rate. 700 divided by 5, that means Charlie can do 140 words per minute. But looks like the record's faster. And so, yeah, you're just comparing the table or the graph with what they are giving you. Word problems are always a little trickier because reading comprehension is involved. So if you have to reread the problem, then do that. So now we're graphing proportional relationships. And by proportional, they mean, when x is 1, y is 8.5. When x is 2, y is going to be 8.5 times 2, which is 17. When x is 0, y is 1. So you can see it goes up 8.5 for the y's and up 1 for the x's. That's a proportional relationship. AKA, it's going to be a straight line. Wait, 0 times 8.5 is 0. Sorry, I messed that part up. 0. So this is at 0, 0, and then it's at 1, 8.5, which is there. And yes, this is a proportional relationship. The unit, so also for proportional relationships, you'll see it in this format a lot of times. Y equals K times X. K is the constant in proportionality. So 8.5 as a fraction would not be 2 over 17. It would be 17 over 2. And like I said, if I did, this is backwards. So it should be 2 for change of X and 17 for Y. So they're doing a lot of stuff backwards. If I were to do 3 times 8.5, I would get 25.5. And if I were to do 4 times 8.5, I would get 34. So yes, a 4 for a change in x is a result in 34 units for a change of y. The unit rate of change of y with respect to x is 8.5. Yes, it is. So all of those are correct. So 8.5 is the constant proportionality. It's going to change up 8.5 every time you go right one for x. And you can make a table and you can see that. And so here they just want you to graph the proportional relationship here. So 1 minute is 60 beats, right? 1 minute, 60 beats. You want to put it where it meets. And we'll just do the second one. 2 minutes is 120 beats. That's not going to fit. So it looks like it's going up by 60. Up 60, up 60. So we need to go back down 60. So then this is going to be at 0, 0. So it's going up for 1 for the minutes. So we need to go back 1 for minutes and down 60 for minutes. And that's how we could fit it on the graph. You want to make sure you can fit things on the graph. And so that's how you deal with proportional relationships. So let me know if you have any questions. For this one, they want to know what's the unit change. The unit change is your slope. Graph the line that represents a proportional relationship between D and T. So D is up and down, which is your y, and T is left and right. With the property that an increase, okay, so 3 units increase for T, 8 for D. So up 8 over 3, up 8 over 3, up. So the unit change is 8 over 3. What is the unit rate of change? Okay, so then up 8 over 3. So I wonder if they just want you to put it like that. So yep, there we go. Okay, so let me know if you have any questions. Good luck.